Did you know that isolated disturbances near the Sun's surface, far from its deeper layers, could grow over time to form the magnetic structures we observe? Recent research has unveiled that the secrets of the Sun's magnetic field, which have puzzled scientists for centuries, might actually lie close to its surface. The Sun's magnetic field is responsible for dark sunspots, explosive solar flares, and even massive eruptions known as coronal mass ejections (CMS). However, astronomers have been unable to pinpoint the origin of these magnetic fields until now. An international team of researchers may be closer to solving this 400-year-old mystery that even baffled Galileo Galilei. This new discovery suggests that sunspots and solar flares might originate from a shallow magnetic field rather than a deep-seated one. These findings could help solar scientists better predict solar flares and geomagnetic storms, which pose risks to Earth's satellites, communication systems, and power grids. Additionally, the research hints at a strange connection between the Sun's outer layers and the feeding processes of black holes. Using NASA's supercomputer, the research team conducted complex calculations showing that the Sun's magnetic field is generated about 40,000 miles 64,000 kilometers below the photosphere. This depth might seem significant, but considering the Sun's radius of about 433,000 miles 697,000 kilometers, it means the magnetic fields are produced in just the outer 10% of the Sun's overheated plasma. Sunspots are cooler, dark spots on the Sun's surface, formed by the tangling of magnetic field lines. Solar scientists have discovered that the number of sunspots increases during the solar maximum period of the Sun's 11-year cycle. Observations indicate that sunspots tend to appear closer to the Sun's equator rather than its poles. The Sun generates its magnetic field through a process known as the solar dynamo. This dynamo operates in the convection zone, a turbulent region where hot plasma moves away from the Sun's core, transporting heat and energy to the surface or photosphere. The research team developed new models that can grow in plasma flow and form a realistic picture of solar activity. These patterns match the sunspot locations that astronomers have been observing since 1612, corresponding with Galileo's observations. The Daedalus Project simulations revealed that changes in plasma flows in the outer 5 to 10% of the Sun are sufficient to create the magnetic structures that explain the observed sunspot activity. Don't forget to subscribe to the channel and turn on notifications for more exciting science and space topics in our next video. See you soon.